Welcome to 3D comparison. This will be an overview regarding assemblies. And the case study will be the following caliper that I already have it open over here. So let's get started. I'm gonna start do the mating over here. So I'm already within assembly and we're gonna see over here the mate tool. By default, Solid doesn't have any hotkey for this. I would recommend you to set this. I would prefer to have it set to hotkey E. If now we're going to press on E, we're going to see that in this case, near my cursor, the following, let's say, pictogram will appear. This will be actually a selection filter. So it's not that useful that we have this. If you don't know exactly what that represents, you can right click over here, go to tabs. In this case, not tabs, toolbars. And this will be the selection filter. And as you can see over here, this will actually be the selection filter over here. So toggle selection filters on off will be hotkey F6. But over here, we're going to have edge filter, which will be E. And that will actually only allow me to select edges. So this is quite, let's say, not that convenient. V will be vertices. So if I'm going to press E, now you can see that I can only select edges. In some cases, if you want to do a mating over here, maybe that can help you. So I can start the mating and I want to mate that edge. And in this case, I can only select edges since I have that filter. And I can select that those two will be in this case the matching ones. That can be good. So usually this is why E is that filter, but I would maybe prefer to have a hotkey for mating over here because this doesn't have any. And in this case, we see that that helped us. But now, if I'm going to move this component, so we currently have the base locked and we have that coincidence. But if I'm going to go and move, you're going to see that I cannot actually move this component. This is the fact that I still have my selection filter on. So the edge over here. If I will just disable that, we're going to see that now the move tool will work like this. So that part actually moves because this isn't constrained, but initially I wasn't capable of selecting that component since I had E, which is that edge selection. If I will select an edge and I will start moving, this will actually allow me to move. So keep that in mind because this is a little bit tricky. And I saw that a lot of new people that are within Solid, they will just press by mistake E on the keyboard and they will not be able to work properly. Okay, so let's see. I will disable that filter, and in this case, to position that slider, I'm gonna go within mate, and I want to mate this interior part of the slider should be matching that plane, and that will now actually slide accordingly. That means if I'm gonna go within move component, and I will start moving this slider, we're gonna see that this will only slide. So if you're familiar with other mechanical tools, this will be similar to a prismatic slider. This is how it is within CATIA. So it will only slide based on those guides. Now we need to do the same over here for the other lock over here, for this one on the back. So one solution would be, if you don't want to do that selection filter, I would recommend this, to just simply move that part from its original position, then start to do the mating. And I know that that edge will be so similar to a puzzle, will match that one. I'm gonna hit OK. You can also do it over here directly. And now we also need to do okay, sorry. We also need to do the same over here for that surface. And if you know within Solid, if you're gonna go on a part, press tab, that will hide that component. If you wanna reveal that, hold down Shift and Tab, and that will make it visible. But the main problem with this is if you actually are within mate and you're going to start do the selection, over here it's no longer working. So if I'm going to press tab, it will no longer hide. And in some cases it's a little bit trickier to select that surface, as you can see. So I have that surface, but now I will need to rotate around and I can locate this. So this will actually be the extrude cut inner face, but in this case that will be a good match. So we have phase 1 and phase 2. I can click OK and I can go ahead. So let me just zoom in again. And if I'm gonna move this, we're gonna see that this will go as intended. Okay. Now over here on this component on the bottom, which will be in this case the roller, if I'm gonna measure this, so I'm gonna go within evaluate measure. If I will measure that distance all the way over here, we're gonna see that this will be 10.16 millimeters. This caliper is actually being modeled within a different system over here, so IPS, inch, pounds, and seconds. We're going to see that individual components will still have that, so keep that in mind if you want to work on the same file. You're going to find the file within a link on GrabCAD, within the description. So I'm going to go over here within assemble, and I know that this distance will be exactly the same. I can also evaluate it, but we're going to see the same distance, 10.60 millimeters. So in this case, we only need to make this to be on the same axis. So I want that one to match this inner in terms of concentric. That means if I'm going to start moving this, it will only move on that axis that is matched between that cutout and this extrude. And I can now go and make this, so that surface will be exactly within that location. And now I only have the possibility to rotate this, as you can see. While I'm rotating this, this will also move the slider, but you see over here the orientation of that pin. Now let's add those screws over here. So they are not actually going all the way to the part, so it's not that the best design in this case. If I'm just gonna do over here a section, we're gonna see that the caliper will look like this. So that cutout will go all the way, but the screw will not actually have the let's say the desired length. So it would be mandatory to go and fix that if you want this to be a working caliper. But the main case study for this video will be mainly the mating. We see over here that I also add that numbering, so this will be where we're gonna have on that caliper that measure for 5. So let's go ahead and mate the screws. So I want that, which will be an edge. In this case, the edge that will define the bottom of that circle, even though it's misleading because a circle doesn't actually have an edge, but within CAD, we see that it has. And I will mate that over here. Now, if I'm gonna start and move this around, we're gonna see that while I'm moving this, that screw will also rotate. So if you wanna lock that in position, you can easily go over here and add an additional mate. Let's say that I want that surface. If I'm gonna select it in this one, it will automatically give me a parallel. That means if I'm gonna go ahead and move this, it will always maintain that position. So let's say that that screw, even though within section it's not fully defined to go and lock to that component, we can consider it to be like this. We're also gonna have this one, which will also lock it over here. So this is actually what will control the slider and allow us to move it. So in this case, not a small screw. Now let's go ahead and add additional mates for the others. So this will be a little bit repetitive, but I'm usually using this example for people that are getting started with assemblies within SolidWorks. So I'm gonna mate those over there. I will mate this. And again, I can just select some faces and that will automatically rotate everything. As you can see, I'm still within the same over here. So we can also match it differently. So initially that position and after that the location. But as you can see in this case, it will not go unintended. So I'm just gonna delete that last coincidence, which is this one, because it's not actually a good idea. As we saw, it moved it and lock it within that position. So I'm just gonna delete it. So it's important that initially we're gonna center that location, and only after that we're gonna lock that tight fitting over here. Okay, we're gonna have the following one. This is usually why it's a good idea to initially assemble the slider and have it slightly offsetted, so you no longer have to select those profiles a little bit more complicated, since they will be overlapped. It will be a lot easier. So I'm going to select that face to match that one. We're going to go over here as well. So in this case, I did a selection for that, so I'm just going to go for that. In this case, this will be already within the desired location. Let me just move it. I think that, yeah, this has already been locked in. So we have all of those 5 small screws for the top. We only have those over here for the bottom. So let's do the same. We have that one. I'm going to select those faces and go over here to the next one. So I don't want the whole face, so usually over here that filter for edge selection is a good idea, but after that, since we want to select that surface, it will require additional key presses to have that disabled and re-enabled. Over here, if you wanted, we could also have this pinned on the interior. So now that I'm adding all of those, I see that all of those screws will actually be quite elevated over here. So it's not actually that well intended, because we want those to be on the interior. So let me just slightly change that. In this case, I'm going to change the mate to be that one over here on the bottom to match the one over here. So this will be regarding the circularity of this, but I also want to match that bottom surface from this screw to match that inner shoulder over here. So in this case, this will be, let's say, a better position for that. You can also go ahead and change that for the others, but the main purpose for this is just to get started with this. And at the end, we're going to discuss some configurations over here, where we're going to have some components locked and other will be free to move. Let's also center this. And in this case, as you can see, if I will select that sweep and this cutout, it will not actually understand that circularity between those two. So I could have possibility to go for the hidden axis, or if I will go with that surface and that one, again, you're going to see that it will not actually manage to match it. But over here on the top, we're going to have a circle, and we can have those concentric set, as you can see. And that means that I can now define that location where we want this screw to be, where that fitting will be. As you can see over here, the overall size for the fillet and the thread is not that well defined, so that should also be further adjusted. You can also check my additional video regarding this, so how to use the hole and the thread features in order to define added depths or dies, so depending on what you are designing. And let's see over here, I will want this to be mated like this, so we're going to have a little bit of collision, but I'm going to leave it like this. Maybe I'm going to leave a little bit of space, let's say 1 millimeter over here. We have over here a little bit of clearance from that, but again, this screw should go a little bit downwards. And over here as well, I'm going to mate again those same elements to be on the same axis, and I want those to be at a distance of 1 millimeter. So we have those in position, and now we have over here a working slider. That means I can move the components, and we're going to have this separated lock. In this case, I will need to move that again, and as you can see, we can also move it. We can also lock them over here together by tying this up, but the model doesn't actually have those fillet over here, and this is also quite small, so it will require additional space over here in order to make sure that that will be locked in position. We can also do over here some collisions, so between all components. And if I will now move this component, we're going to see that it will not actually interact with those. So it will not see the collision and it will not stop over there. If I will hit OK and go and move this one, again, we're going to see that it will ignore that. So let's see, within previous versions, it allows us to stop. Let's see, sensitivity now, if it's set, model start a collision position. So there are some collisions over here on the parts. So this is why the dynamic will be stopped. Within previous version of Solid, we could easily do this. So within move, if there was a collision, it would stop. It would detect those quite good over here. But let's say stop on collision. If I'm just gonna move this, even with this, with collision stopped because collision is enabled, and we're gonna see that it will not actually stop over there. So with collision, that will not be a viable selection. So within previous version of Solid, this was quite straightforward, but I see over here that there are some changes, and let's say between this component, that and that, and again, that stop on collision will not be available. So I don't want to do any selections. Let's see, move component. As you can see, I'm over here within those in order to do that selection, but I also don't want to add anything. I just want to resume the drag. So you need to click on resume drag so that it will allow you to move. But in this case, we're going to see that again, it will not stop on collision. So I will need to further investigate and see exactly what changed within this version of Solid, because it used to work really good with that stop on collision. And that was something really interesting, but now I think that due to the fact that this is not a very accurate model and we're going to have some collisions over here, as we can see, between those threads, the model will not work as intended. So I can make that lower, I can increase the cutout for the hole in order to have those disabled. But let's see, some configurations. Let's say that we want both sliders to move together. One solution would be to just link those within a mate, but we can go over here within configurations. This will be the default where nothing will be linked. I can go over here and right click and I can add a new one. I'm gonna type in lock together. I think this is the correct spelling. I'm gonna hit OK. And within the lock together configuration, which is now active, I'm gonna go and I will make an additional mate between that face and that one over here. And I'm gonna hit OK. And as you can see, if now I'm gonna drag, these will be locked together. But if I want to go back and I don't want to have those locked, I can just double click on default. And what actually happens over here, if you also check my previous video regarding configurations for the hinge, if not, I highly recommend to do so. If I'm going to go within mating, we're going to see that in this case, this coincident will actually be disabled. So I don't have to manually go and have it suppressed, because that configuration will just do that over here. So I have those well defined over here. Now we can further go ahead and we can do the changes for this caliper, because as we saw, there are some collisions. Also, you can consider to go ahead and add over here those values. So we see over here where that segment will be located. I made over here one mark with 5, but if I'm gonna measure this, let's say from that point all the way over here, we're going to see that this will be roughly around 5. So we can just add that coincidence, not over here on that edge. You can make it directly from the line over here, and you can type in, for example, 50 millimeters, and that will be that mark. But as you can see over here, that that sketch will also have over here a number, and that number is actually can be controlled, the position of that. If I'm gonna drag it, we're gonna see it will go like this. So you can add additional construction lines in order to have this defined for all of those. You can also go ahead and you can search for some Caliper images. I think I already have some of those over here. So as you can see over here, I have this reference. So this will be for the MMGS. And as you can see, we can have that locked over here for 5. We can measure that distance. And you can also consider to add a logo for this. For example, you can add Mito Toyo. And you can consider exactly where exactly you would like that to be positioned. Maybe over here on the front. We're going to have over here also that section that will allow us to measure other elements. Then we have over here the one for the interior dimensions. Okay, so I hope you enjoy this kind of content. You're going to find the 3D model linked directly on GrabCAD, and I would recommend you to go ahead and modify this and make this caliper functional and well defined to have all of those elements added. So I hope you enjoyed this kind of content. I'm going to start creating additional SolidWorks videos within the near future. I know that the vast majority are for Katia, but I feel like SolidWorks has a lot wider, broad audience, and I want to create content for this as well. So I hope you enjoyed this content. You're going to find a similar video over here on the left side, and I will also add a subscribe button to the right. So that's it. Thanks for watching.